Hello. Welcome to Cloud OnAir live webinars from Google Cloud. My name is Shingi Samudzi, and I am a Machine Learning and Artificial Intelligence Operations SME here at Google Cloud. You're watching a how-to webinar session on supporting AI and ML workflows while leveraging Looker and Google Cloud tools. You can ask questions anytime by submitting them in the box below this screen. We have Googlers on standby to answer them. Let's get started. For our agenda today, we're going to talk over three high-level areas. The first we're going to do is frame the problem. And with this framing, we're going to first look at the specific personas that we're targeting with these workflows. And we're going to look at the kinds of problems that these personas face and how and why data governance is a great solution to get started on automating these ML and AI workflows for them. Next, we're going to demo some solutions. We're going to look at both an interactive solution. So for those data scientists who prefer to do all their modeling interactively, as well as a solution for automating the entire workflow. So starting from Looker and with a click of a button, driving through an entire automated workflow. And then last, we're going to do some wrap up and have some takeaways and understand the prerequisites that are required to actually make all of this reality. Jumping into framing the problem, what are the personas that we are targeting? There are two data scientist personas that we're concerned about with these workflows. The first is the citizen data scientist, and the second is the expert data scientist. The citizen data scientist is a term coined by Gartner, and it refers to an advanced data analytics professional or data professional who needs or wants to implement machine learning technology. The expert data scientist persona is someone who possesses both the skills and knowledge to understand and engage all the stages of the data science lifecycle. Most expert data scientists would prefer to work with data engineers and machine learning engineers to offload some of the data pipeline setup so that they can focus more on the modeling and the insight generation aspects of machine learning or data science. So with these two personas in mind, what are the specific challenges that we're solving? From the standpoint of the citizen data scientist, there are two high-level challenges that they face. One is that they're generally strong analysts or subject matter experts, but they lack one or both of the technical skills and statistical modeling knowledge to actually execute a data science project on their own. The second high-level challenge that they're facing is that they're under pressure to answer increasingly complex questions that require either modeling or forecasting. From the perspective of the expert data scientist, they have three challenges. One is that they're viewed by business stakeholders often as an expensive cost center, and so they're under pressure to show value add to the business and in a hurry. Number two is that they often have to build and manage their own data pipelines in addition to the actual modeling that makes up their job description. And number three is the lack of dedicated support in the form of data engineers or machine learning engineers to do the upfront data cleansing or the productionalization of models, which often causes them to spend most of their time on problem number two, which is building and managing their own pipelines. And this is kind of a vicious cycle because it feeds the perception of poor value from data science investment. Based on industry surveys, something like 45 to 50% of the average data scientist's time is spent purely on cleaning data as opposed to modeling. And given salary levels, that can feed the perception of low value for spend from a business stakeholder's perspective. So this is where data governance and more specifically Looker can come in to help support and deal with these high-level problems that both of our personas are facing. The old, or more accurately, the current way of managing data is something like what we see on this slide here, where different end consumers of data have their own completely separate and different data pipelines that they use for transformation. So you might have the data scientist who develops their own productionalized ETL workflows, may or may not be using a data warehouse to centralize their data, doing manual modeling, and from there providing their model results. And even there's some question around how the model results are even socialized across the business. Next to data scientists, you may have other analysts who, from different data sources, ostensibly pointing to the same thing, are leveraging either spreadsheets or other third-party BI platforms to generate the required BI reports. So it may be a CRM, it may be Google Analytics, or a wide range of other various data sources based on the business function that are being pulled in and having reports essentially generated in a silo across the business. Obviously, this way of doing things, particularly from a data scientist's perspective, is incredibly inefficient, especially since at the end of the day, all of these different functions want to be reporting off of the same single source of truth data. And so that's where we look at a governed perspective, where instead of having disparate and siloed data pipelines, you essentially have a single data pipeline where your data sources coming from your potentially application inputs, from your e-commerce inputs, from other inputs within your business are all essentially productionalized within an ETL process that is shared across the entire organization. And you're leveraging a data warehouse. So from a Google Cloud perspective, that would be potentially BigQuery. All of your data is stored in this centralized warehouse. And so this warehouse acts as your central clearinghouse or your central source of truth, where all of your data for analysis or data for consumption is resourced from. Adding an additional layer on top of this, a governed layer with a platform like Looker, turns accessing data into essentially going into a retail type of environment. So depending on your function, you may access a specific data set within Looker, which acts as a semantic layer for interpreting the data that you have within your warehouse. From a machine learning or AI perspective, what this means is that you are essentially able to leverage and scale your data acquisition process by using the same muscle that the rest of the organization uses. And so of that 45 to 50% of time that's spent cleaning, now you can reallocate that time to your modeling. So training your models, to generating reports, generating insights, and figuring out how to distribute across the organization. And even there, Looker can provide additional value because, again, you can create somewhat of a closed loop by feeding your model results back into your data warehouse and then surfacing it within Looker for other aspects or areas of your business to access. So, what is Looker? Looker is a browser-based SaaS platform that connects to any SQL database. They say today, every company is a data company. Organizations collect and store data on any number of things from any number of applications. SaaS apps such as Salesforce, MailChimp, and Zendesk, heavy read-write operations in transactional databases like Oracle, IBM DB2, and Microsoft SQL Server. They could be business planning tools such as SAP, NetSuite, and Oracle. Business analytics products such as Google Analytics or Adobe Analytics. So these are just a few examples. Again, any data stored in a SQL database can be supported in Looker. Looker's agile modeling layer allows developers to explain through LookML models, which is Looker's proprietary modeling language, how the database is structured, how the tables and columns relate to each other. Looker takes this information, and as business users explore and analyze your data, Looker constructs SQL select queries to send to the database. So it essentially abstracts the Looker modeling language into SQL queries that are then sent to your database and grabs the results that your business users are specifically looking for. There are 3 different ways that results can be surfaced. You can surface results through your web interface in the form of what we call explorers, which are essentially drag and drop report builder interfaces. They could be through dashboards, and they could be through looks, which are standalone reports or visualizations. You can also schedule data deliveries. So you can schedule dashboards, you can schedule looks to be sent to specific email addresses or sent to, say, Google Cloud Storage buckets every week. You could also embed your explorers, dashboards, or looks within other websites or applications. And we have a REST API as well as an embed SDK, which allows you to retrieve, analyze, and transform your data and metadata from your Looker platform onto a custom application. One major benefit of this agile modeling layer is that it saves data teams and business analysts a ton of time that would otherwise be spent manually writing and editing SQL queries, or even worse, having to go even further upstream and creating your own data pipelines. The other major benefit is in the form of data governance, meaning that we can define a single source of truth where everyone in the business understands and trusts the data that they see in front of them. Now let's jump into demoing some solutions. As I said before, we have two specific workflows to illustrate how Looker plus Google Cloud can support both of the user personas that we've identified, both our citizen data scientists as well as our expert data scientists, in productionalizing machine learning and data science workflows, leveraging this governed platform or model in which you and the entire organization are essentially sharing a centralized data source. So first we have our interactive workflow, and then we're going to jump into our automated scheduled workflow. For both of our demos, we're going to be using the same base scenario, in which case we are a marketing analyst who is tasked with forecasting over the next 30 days which customers have the highest churn risk and which customers need to be targeted for a retargeting campaign. So the two demos will deal with different approaches to leveraging a data science workflow with Looker as our data governance layer. So in this first demo, we'll be walking through more of an interactive modeling session where we'll be using a Jupyter notebook to interactively build out the model. And our second demo will cover a more, maybe we call it automated workflow, where we will trigger a workflow from Looker, things will happen in the background, and then our data gets returned to us. So to jump into our first example, I'll start with the GitHub repo that contains the actual Looker API implementation that we're going to be using. So both of these demos are going to be using the R programming language. Now, you're not limited to using R. You can use Python or other data science modeling languages. R is simply my background and my preferred language of choice when doing these types of activities. So I'll show you a Looker API implementation for the R programming language. And so this is what we use for our jumping off point. So it starts by grabbing what's called a look from Looker with a specific distinct look ID and bringing it into our modeling environment. So from a Looker perspective, a look is a saved query. So to give you a sense of how that works, I'm going to jump into the look that we're going to be using. So this is using the famous CDNow data set, which is essentially a 2-year data set from an online CD selling company. And we'll use this as our data set or dummy data set for actually generating our model results. So we start with this look, which is our saved query. And the way that Looker develops this is, and I'll jump into the actual environment, our Explorer environment, where we're actually building the data set that we saw in that saved look. And you'll notice on this bottom bar where our actual results are, you'll see a tab that says SQL. Now know that this is the SQL query that Looker generates based on the fields that are selected. And when we say that we're saving it as a look, this is essentially what we're doing, is we're saving this query into a singular report view that we see encapsulated right here. So again, keep in mind this ID 325. So what we're going to do now is jump into a Jupyter notebook using the R kernel. And this will allow us to do our development of our model within R within a Jupyter notebook. So the first step is to install and load all of our key libraries, as well as set the environment variables to actually connect with our Looker instance. So as you can see, we have from GitHub the Looker repository, and we'll make this available to all webinar attendees. So this is a public repository that you yourself can use for your own modeling efforts. And we also have some additional packages which are helpful for the actual model that we're going to be implementing. And in this case, we're going to use the beta geometric NBD, which is one of the many different popular customer lifetime value prediction models that are widely used. So we install our libraries, and then we load all of our libraries. And then what we're also going to do is load a core function. This one is to provide BigQuery authentication using OAuth. And what this will allow us to do is connect to our BigQuery data warehouse, because we're going to be sending the results of this modeling effort back to BigQuery so that we, again, close the loop with Looker so that we can actually build some views within Looker based on our model results or our model output. So the second thing we're going to do is actually point to the look that we identified. So it's look 325. And we're going to run the getLook function from the lookr package to actually load our data. And so it loaded our data. You can see 4 columns from our export here. 4 of the 5 columns we've loaded, because here we're just renaming these fields and we're only picking these 4. And checking the shape of our data, we can see that we have 4 columns. 1 is numeric, which corresponds to the customer ID. 1 is a date format, which corresponds to the data transaction. 1 is a field that has the number of items for each order. And then we have a 4th column, which is sales, which is also numeric. And that's just the total value of each individual sale for each date per customer. So the next thing we're going to do is then start actually getting into the nuts and bolts of our model. So we compute the average order size for each customer, and then we set our prediction horizon. And so we have then our customer level parameters data set, which we then feed into the beta geometric NBD model, the negative binomial distribution model, to actually predict our customer lifetime value for each customer over our 31 days. So we run this function, this BGNBD RDF function, to actually generate our predicted customer lifetime value. And we've done some quick visualizations just to give a sense of the distribution of CLVs across our customers. So we've generated a histogram as well as a density graph below. And then what we're going to do with our results, we're not really going to do too much with it in our notebook. We're just going to ship it back to BigQuery, because again, the goal is to view this data and report on this data through Looker itself, as that's our platform for socializing the results. So we've run that function that we initialized earlier, the provide authentication through OAuth. This allows us to then actually connect to our BigQuery instance. Once we've connected, then we're able to run the function from lookr package to create BigQuery table, pointing to the BGNBD RDF table that we created, or data frame that we created, and saving it as cdnow CLV prediction. So we run this, and it then saves that data frame to a new BigQuery table. And so now it's available for us to pull within Looker and then model against it. So jumping back into Looker, we go into the modeling portion of Looker, where we actually build out, using Looker's modeling language, the dimensions and measures that we want from our CLV prediction table. So you can see, using this SQL table name parameter here, we're able to actually point to the BigQuery table that we created, the cdnow CLV pred table. And we built out a number of dimensions and measures from all of the different fields that were generated when we created our customer parameters table in that first step of our modeling. Then what we've also done is created some additional dimensions that are specific to reporting here that will help us identify what our churn risk is. And so we use case statements to essentially break it out so that we can create some nice visuals on a dashboard for our business stakeholders to see which customers represent the high churn risk. And then we also add some additional measures to then just capture some model accuracy, because in addition to providing our data, what we also want to be able to do is provide some honest look at how reliable the results actually are. So now that we have all of this built, we can put this into a dashboard, which I've already done ahead of time. And you can get a sense of what this might look like for an end user. So we have both our predictions. So we have our predicted 30-day churn risk for all of our users. And then what we've also done is segmented this churn risk by number of customers, just to give us a sense of what portion of our customers, what percent of our customers represent loyal customers versus customers who may be either less frequent buyers or just a generally higher risk of churn. Below that, we also have some indicators of model performance. So we've predicted the average variance of prediction. So essentially, our predicted values on average are about 7% less than the actual values that we saw for the 30 days. And we can also see the distribution of variance. So even though the 7% less doesn't seem that bad, we can actually see from the prediction variance that we've generated here that this -7 just really comes from being way off on a handful, as in predicting less than the actual value for a handful. But in general, the model is not extremely accurate, so we would likely want to use a different approach to generate something more accurate. But again, this is not necessarily a how do you generate CLV type of demo. What we're really trying to just illustrate here is how do you actually go from your data that's presented and available within Looker, bring it into your modeling environment, do some interactive modeling through a notebook, and then close the loop and provide the data back into Looker. In our next demo, we're going to walk through an automated version of this same type of workflow. Keep in mind, though, that instead of using the Looker API this time, we're going to be leveraging a more Google Cloud workflow-centric approach. So again, hopping into our actual environment, we're going to revisit the look that we were looking at in our first demo. So look number 325. So again, this is the same transactions data set from CDNow that we looked at in the previous section. Now this time, instead of moving into an interactive modeling environment, what we're going to do is actually use what is called a Looker data action to kickstart an automated workflow. This automated workflow is going to essentially involve us saving a snapshot of this particular look to a Google Cloud Storage bucket, which will then kickstart a pub sub subscription that will trigger a cloud function that will spin up a VM that will run our Jupyter notebook that we looked at in the first demo. So instead of interactively running this notebook, we're going to run through it in a more automated fashion. But again, the end result of that will be to send data to our BigQuery table, and then we pull that in to close the loop back into Looker to build a model on top of it, and then publish the results onto a dashboard. So again, the same end result, but instead of a more manual or interactive process, we're going to show you how to do this in a more scheduled or automated fashion. Okay, so our first step, now that we're back in our look, is to actually run a data action. And the way that you can access data actions from within Looker is to jump within your look to the gear in the top right corner. And we're going to click on send. Now you can also do this with schedule. So I'll show you both workflows. So for scheduling this, what you'll do is select the appropriate integration. And so in this case, we have a custom version of the Google Cloud Storage that I've created specific to this type of workflow. Now what we'll do is send it to a specific bucket on which there is a pub sub topic listening in on. So in this case, I've called my GCS bucket notebooks bucket looker. Now I have a very specific file name that I'm going to give it, and I'll show you why in just a few steps. But I'm going to call this looker.csv, and I'm just going to overwrite anything that's already there. Now, from the purpose of scheduling this, my trigger is going to be a repeating interval, and I'm going to then select my interval. So in this case, let's say you want to send this every day at 6 a.m. So in other words, what this means is you essentially want to rerun your model every day at 6 a.m. And then below here, I'm just setting some additional parameters to limit what data gets sent over, and then to ensure that all results get sent instead of some defaulted row limit of, say, 500 or 1,000. So if we want all results, we'll select that. Now, we can do the same thing, and I'm just going to ignore this for now. Now, we can do the same thing for just sending the data, triggering it once instead of scheduling it. So it's going to be a very similar type of interface here, where instead of schedule, we're selecting send. We're selecting the integration that we want. Again, Google Cloud Storage. Again, we're going to select the appropriate notebook bucket. In this case, it's notebooks bucket looker. Same file name, overwrite, have our filters, etc. And from there that we can send. Okay, so now that we have selected the specific look that we want to send over, and we've specified the bucket that we want to send to in the file name, let's see how we've actually triggered this workflow. So our first step is to then look at our Google Cloud Notebook where we've sent this data. And we can see that we've sent over this looker.csv. It's the same CSV, and you notice that it's not very big. It's only 2 megabytes, so not a ton of rows. So it was a pretty quick thing to send over. So notice, though, the way that we've triggered this workflow is that we have essentially 2 PubSub subscriptions that we've sent. So going over to PubSub really quickly, you can see the 2 subscriptions that we've created. One is a pool delivery type that I've called Looker Action Import Sub. And this one is looking at the Google Cloud bucket right here for any changes to this bucket. And essentially the workflow gets triggered on any change that happens to this bucket. And so what is triggered is the second push PubSub subscription. This is the name of the cloud function that it triggers. And so this one triggers a cloud function. And you can see our endpoint down here. We trigger a cloud function that will run. So basically this cloud function will spin up a VM that has a VM with the specs for a deep learning machine. On that, I will run the Jupyter Notebook that we looked at in our first demo with some slightly different variations, which we'll get to in a second. But just to reiterate this point, in this stage, we have both of our subscriptions configured so that this second subscription is configured to trigger on the first subscription being executed. So again, we look at our action import, right? And then we can see the second one right here, which essentially triggers our cloud function. Okay, so now once we have our message sent, and we can go back to our first topic here, we can see that we have a couple of message sent, right? So we've sent our message from triggering the change on the bucket that we saw, which was the action that we drove from Looker that saved the CSV. Now we're going to trigger our cloud function. So this is the cloud function that I was referring to, run CLF basic. And this cloud function, as I said before, it spins up a virtual machine that has essentially a deep learning platform. So it has the specs that you would want for a deep learning type of project. Now, obviously, the analysis that we're doing is not nearly as CPU or memory as intensive. That would actually justify that kind of horsepower. But again, this is just to illustrate the broader point that if you had a more intensive analysis that you wanted to automate, this would be the kind of VM that you would want to use to spin up. But in our particular case, we're just going to be running that same basic notebook that we ran before, and you can see the notebook name that I'm pointing to. In order to pull that up, I had to then configure all the necessary Google Cloud Project items. So there's a notebook executor script that I'm basically running once this bucket gets started up. This will inject variables that this shell script is going to run to actually execute on the cloud notebook or the AI platform notebook that we have set up. And then you can see that our entry point is essentially this function right here, this execute function right here. So again, we trigger it from our pub sub topic. So then our next step is to run that shell script that we have stored in this particular bucket right here. And it's a very familiar CLV with our beta geometric NBD function running. Although in this scenario, instead of running the Looker API, what we're going to do instead is load a package called Google Cloud Storage R. And so what this package allows us to do is, from within R, manage grab objects from Google Cloud Storage. So in this particular case, we're going to fish for that same CSV that we sent from Looker to Google Cloud Storage. So you can see that's why I provided this generic name and have it overwritten, because since we're not able to interactively manipulate this notebook and it's going to be running on the same thing, I'm keeping a very consistent name within our cloud storage bucket, and I'm overwriting it. So this basically only looks for one specific file in this bucket to be able to run this entire thing. So as we can see, it's the same specs, because again, it's the exact same thing as this look number 325. We're just saving it as a CSV instead of using the Looker API to pull it in. So everything that you see running here is going to be the same as we saw in the first demo, including overriding the previous table. So it's going to have the same results since we're basically running it the same time, once after the other in short order, and there's no new data. But again, if this was something that you were scheduling and you had consistent new data coming in, this would essentially be your pathway or your method for rerunning this model over and over again with new data to continuously update the dashboard that you then circle this back into a closed loop. So in our scenario, jumping into Looker, pointing at the table that we created in BigQuery, right? We've modeled all of the parameters that were generated by the model, as well as the output. We're then adding some additional dimensions so that we allow ourselves to do some color coding and identification of the high churn risk customers. And then we're adding some additional measures, again, to track model accuracy. And so again, this is the same dashboard that we saw in our first demo, where we have our customer lifetime value predictions with our 30-day churn risk and our projected spend within the next 30 days, as well as segmenting our 30-day risk just to kind of see the numerical comparisons of each risk group, as well as data on our model performance so that there's a bit of transparency around the reliability and the accuracy of the model that we're presenting. So again, this second workflow represents more of an automated way of doing the same thing. There are benefits to doing either one. The benefit of the first case is that before you've productionalized anything, you need to get a sense of what models actually work. And you ideally would want to use the model performance data that you're pushing back into Looker as a way of broadcasting to your team, or what changes need to be made to the model, or what different approaches might need to be taken, or even what additional steps need to be made before this gets productionalized. Obviously, once you get to a point where you are ready to productionalize, then you can leverage the second demo, which actually has a more scheduled or step-by-step workflow that doesn't require hands-on outside of the initial deployment. One thing to keep in mind after looking at our two demos is that they represent two out of a myriad of possible ways to build out use cases for supporting your ML and AI workflows. What that means is that depending on the user type or user persona, whether it's citizen data scientists, your intermediate data scientists, or your advanced data scientists, and depending on the specific business use case, there are many different paths that you can take from your input data to your end model results that you can then socialize to the rest of your organization. The important commonality here is that Looker plays a central role in both the data governance component as well as the ability to then socialize and provide decision support, leveraging your model results for other business stakeholders. So keep in mind, Looker itself is not a data science platform. However, if you take the approach of focusing on governance, Looker provides that stable platform that helps data scientists save an incredible amount of time because they're not having to worry about building their own data pipelines or cleaning their own data. Now they have a well-governed, QA'd, single, trustworthy source of truth that they can take data from and then do any kind of last mile transformation that's going to be necessary for the specific algorithmic approach that they're going to be taking for their specific analysis or specific problem that they're trying to solve. Jumping into wrap up and takeaways. There are three things that I want to really hit home that need to be in place for any of this to be implemented within your organization. First and foremost, the most important component is a data culture where data is treated as a product. So quote unquote, data as a product. In other words, we treat data and insights that are used to drive your data or business decisions as a product. And what that means is instead of haphazardly creating data pipelines based on new reporting requirements, we think very strategically and we think from a process and operations perspective, how we are sourcing data, how we are transforming data, and how we are making data available to all of your different end users, right? So we take the same principles that are applied when you're creating an application that you're going to sell to customers or some other product that you're going to sell to customers. You take that same mindset and you apply it to the data that you make available, treating your internal employees, your internal data consumers within your organization as customers and the data that's being provided to them for their work as a product. The second prerequisite that needs to be in place are production-ready data pipelines as well as ETL. So by that, what we mean is we need a scalable approach to transforming data from all of the different inputs. So you as an organization may have a CRM that you're using. You may have e-commerce analytics or website analytics that you're using. You may have a number of other different data inputs that are driving different functions within your organization. You need to be able to implement productionalized pipelines in ETL or ELT in order to scale that transformation and implement the entire workflow that we're talking about in terms of being able to automate and support your data scientists and being able to cut out the amount of time that they need to make continuously to build their own data pipelines. And then lastly, the last prerequisite, which relies on the first two prerequisites being in place, is Looker as data governance. And so again, we need to have this product-based approach to distributing data. We need to have this central clearinghouse for data as truth, or single source of truth. And you need to have production-ready pipelines and ETL in place in order to make best use of Looker as the platform and the strengths that Looker provides from the governing perspective, from the semantic layering perspective, as well as from the data as a platform to be distributed for further last mile use. Thank you for tuning in. Please visit cloudonair.withgoogle.com for more hands-on learning, training, and demos from Google Cloud experts. See you next time.